network management. We have 4 talks today. The fourth talk is from An Changqing professor. Her topic is the updates of the joint IPv4 project. The second talk is from Zhang Xianli professor. His topic is global cyber service serving and managing report. The third topic and the fourth topic are the user experience of BGP Watch platform. Now let's begin our first talk from Professor An Changqing. Thank you.
Thank you. Hello, everyone. Today, I will present our progress on the joint research on IPv6 and IPv management. Our topic includes 3 parts: the project outline, work progress, and the summary and future work. Here is our project website. You can access it. This project is an international cooperation, comes from 14 countries and 23 research organizations, and it brings excellent mix of key experiences of IPv4 and IPv6 network management, and it will promote network technology innovation and application demonstration. The project started from June 2020 and it will end at June 2023 is this year. For better cooperation, we have set up 6 working groups, that is passive traffic management, active probe, network looking glass, and BGP, route information sharing, monitoring, and network telescope, and international rules of sub-governance. This is the work progress. We will cover 5 aspects. First, we will show you the active probe platform. We call it GPRF. GPRF, this is the architecture of GPRF. It can be divided into 3 parts: the web user and the web server and the probes. Users can init detection tasks, view results, and probes by the website. And at the back end of the web page, the server is responsible for distributing tasks to designated probes after user initiate their tasks by website. The web server is also responsible for communicating with probe hosts. It gets processed and storage results from the probes. This is the homepage of this system. We can see all the looking glass probes and some probes we have deployed. And this is a running task number. This page shows the available probe list. We have some probes from our partners, such as Singering and Terring and Myring, and all they have installed the probe, and so we can use their probes. And also we rent some cloud machine and we install the probes. So how can you create your probe task? It's very easy. Just click the task and then click create task group. Here is the pop-up window. You just can input the name and input the website you want to monitor and select the probes you want to use and set the period. So this task is created. It's very easy. After the task has been created, you can stop it, delete it. Also, you can click the in to see the results, the proper results. This is the task results that we can see. Each website we monitored the response time, the ping response time, and the HTTP response time. And also you can click the info button and see more detailed information. Here are some information that, oh, sorry. So we can see that's the results, the HTTP connect time and the HTTP download speed. Also, at the right of the page, we can see that each probe they may use different routing paths. This page shows the routing path of each probe. So next, the passive traffic measurement, we call it flow watch. The input traffic can be raw packet or net flow traffic. The machine will listen on the NIC card and receive packets and extract packet metrics, match active flow, and then identify IPv type of the flow, and then update the flow statistics, write it into database. We use some speed up techniques. Each flow has a unique ID, which is hashed with its 5 tuple, so it's fast to match the active flow that one packet belongs to. This is the architecture of the system. It have 6 layers. The lowest is the classification layer. It will classify traffic into application. We use NDPI to do the classification. Then we use the middleware Kafka. As it will distribute data to different machines, so it can deal with high traffic. And then the transaction layer will aggregate and do statistics of the data. And the MongoDB can be clustered, so it can deal with high traffic. This is the web page. We can see the top 10 application used by bytes, by packets, and by flow number. Also, we can see the statistic information of each application. And we can see the top 10 IP address, their bytes, their packets, and their flow number. We can see the detailed information of each application, the history curve of all the application, or we can see the detailed information of one application. And we can see which IP address use this application and the traffic information. Also, we can see the detailed information of one IP address, the flow speed, and also the traffic speed by kbps and by pps. All the information users can see. This system has been deployed. This is the detailed information of each flow. We can see the packet number, the byte, and the start time and time, and port they used. This system has been deployed at Run, and we can see that the bandwidth throughput is very high. It can reach 10 gigabits. Also, it has been deployed at Terrain and Learn, and this is a screenshot of the system. Next, I will introduce network looking glass. We call it CGTF looking glass. This is the architecture of the system. We have a looking glass web server, and we have some, and all the routers can connect with our looking glass web server, and the web server can SSH to the route and can do some commands. Here you can access the website. We use open source to implement our Looking Glass website, and now it supports 5 commands. And also we set a query speed limit for security reason. And now we have 7 education and research network joined us. Also, we do some work to search available Looking Glass in internet. We have published it in the paper. This is a paper named Discovering Obscure Looking Glass Sites on the Web to Facilitate Internet Measurement Research. It has been published in Connext 21. We find over 2,000 Looking Glass websites. Among them, over 900 are obscure Looking Glass web points. They distribute among nearly 300 cities and over 50 countries. These over 900 obscure web points cover 8 exclusive countries and 160 exclusive cities. No Looking Glass have been found here before. Among them, the 8 countries are mainly distributed in East Africa and South Asia. Here is the URL. You can access the open source and all the data here. Now, next, I will show you our BGP routing sharing platform. We call it CGTF RIS. This is the architecture of our BGP routing sharing system. Here is our collecting server, and we use routing FRR to simulate a real BGP router. And the board routers from our partners, they can hear with our collector server. So the route information, we collect the route information and periodically export them into the database, and users can download and use the BGP dump tool to pass the metadata via HTTP. Now we have 15 partners have established the BGP session with us. Here are the configuration menu can be accessed at this URL. Here are the partners that have established the BGP session with us. All the shared information you can access here. We will share the URL to you so you can access all the data. Here is our CGTF risk collector information. This is our collector SN number, and we have 2 collectors. This is the IP address, IPv4 and IPv6 address. So with all this data, we do some analysis. This is the BGP routing monitoring and analysis platform. We call it BGP Watch. I will just give it a brief introduction because after a while, Dr. Torit will give some user experience to this system. This system have such functions, including hijacking detection, hijacking statistics, and dashboard as information, show as information, and routing search. You can search forward, reverse, and bidirection routing through this system, and you can subscribe and you can receive alarming information. For hijacking detection, mostly we have knowledge-based real-time BGP hijacking detection system. We use public BGP event. We public BGP event reporting service, and we do all the hijacking detection based on MOAS. And we use the domain knowledge from ROA, RR, and S relationship. All this information. This is a URL of our system. Some features, it can be response quickly, And we have event replay, so users can know how the events occurred. And it can give different level of the events, so users can know which events will harm the internet and which will do little harm. Also, we do some statistics by country and by IS and by prefix length and some historic curve. Also, users can do statistics by country region and can buy yearly, monthly, and weekly and daily. I think it's convenient for users. This data is for basic information of an IS. User can input any IS number and he can get all the basic information. This page shows the key partners of the IS, the provider and some peers and some customers and some statistic information. Also, this is for IPv6. For routing path search, we have forward routing path search. We have done this for our partners which have paired with us. If you put an IP address, it will return all the subnetworks and supernetworks of the prefix you input. Also, the system will group prefix with the same routing path, so you can have a high overlook of your network routing path. Also, we give reverse routing paths so operators can know how traffic was sent to their. Also, this is another interface. It's also for reverse routing paths, but it can interact well with operators. Also, we can provide bidirectional routing path search, so we can see how about the two-direction routing paths. Mostly, the path may be asymmetry, as shown in this page. Also, users can subscribe their prefix, their S, and now when the prefix change, the user will get an alarm email. Also, we have some initiative on the new governance rules. We think that we should strengthen the role of United Nations as the main channel and enhancing degree of participation of ICANN. And we should deepening security cooperation mechanisms, and we should systemize governance rules by discussed by all the entities of the internet. And also, we should promote shared development benefits sharing. We have drafted some proposals. It's a scholar's proposal. We have proposed some initiative that we think that maybe a credit system will enhance the collaboration among all the partners of the internet. So this is a brief summary and about future work. After all, we have done something on active probing, passive monitoring, and B2B routing looking glass. We will keep working on improving internet security, and we welcome suggestions from Internet Society. And we welcome more partners join the community. Please contact us. This is our email. You can contact us. Thank you and welcome for your comments. Thank you. So any comments or questions? So, yeah. Yes. Yes, yes. You mean that the at APAN we don't have a session. Maybe after a while we can set some meeting with our partners. We haven't a meeting, have no session of on that rule. Yes, we can discuss in detail. Thank you. So, any question?
Thanks from the talk of Professor An Changqing. Next talk, we will in our second talk from Professor Zhang Qianli. Professor Zhang Qianli is an associate researcher from Tsinghua University. His research includes network management and his topic is about global cyberspace survey and mapping report. Cyberspace survey and mapping is important to understand the current internet. They implemented a cyberspace mapping on global routing infrastructure and internet services. His talk will present several findings on routing robustness, possible BGP hijacking distributions, and list of internet services. Now, let's begin the talk.
Okay. Thank you, the chair. The next 20 minutes, I will introduce our efforts on global cyberspace survey and mapping report. The global cyberspace survey and mapping report is conducted by the Tsinghua University and Qinhu Technology Joint Research Center. This is the first report in our cyberspace survey and mapping implementation. The talk is divided into 4 subtopics. In the first place, we will introduce the background of our research, and secondly, we will put forward our motivations, and followed by methods and results of our survey and mapping performance, and at last we conclude. Firstly, the background. We are the Tsinghua University Qinhu Technology Joint Research Center for cyberspace. This joint laboratory was established on January 13, 2022. Its main efforts is included the cooperative research on the cyberspace research mapping and surveying. Also, we implement some global cyberspace survey and mapping implementation and get some interesting results. Let's start with the background of real-world surveying and mapping. In the real world, the surveying is the process of collecting, analyzing, calculating, valuing, integrating, and managing for a land with its geographic information, and then to enhance the character of spatial layout. This is copied from Wiki. Its definition. The mapping is the process of using the information from the surveying. It's used the information collected from the surveying process. It's displaying specifically the terrain features and surface features and the varieties of natural and human materials according to the result of survey, and such information and visualization can help us in the transportation, logistics, and all kinds of our necessary real-world life. It is very important in our daily life. It's, as you know, the cyberspace survey and mapping is quite different. That it's come as the internet become the one of the major new space, narrow space. The cyberspace come from the invention of the internet. As you know, the internet, the invention of the internet brought forth very revolutionary change in our daily life. We can every activities we have a cyberspace mapping, and there is many of different activities in cyberspace. So the cyberspace has become the fundamental of our society and a necessity of our world. It's very different from real world. So what is the cyberspace survey and mapping? That we want to answer three questions. The first is what we want to survey. What is the entity we want to survey? What is the thing we want to survey? And the second question is what we want to know about this thing and these entities, what we want to know. And the third is how we do this survey and mapping. Let's start with the first question, what we want to survey. It's a network architecture problem. So what is the internet basic components? What is the basic building blocks of our internet? We think the building block of internet, oh no, the building block of internet is, oh no, it's the building blocks of our internet is make up of the basic process of our client to achieve the services. Is the process of our client to achieve services. So as you know, the internet is divided into the user and the servers, the client server model. The client server exchange information and achieve the results. The packets as the entity to exchange information, they must use they must they must have a routing system to support them. The routing system is used to help the packets from the user to reach the servers. So what we are interested to, what we want to survey is two entities, the routing system and the services system. This is the entity, the thing we are interested in. The second problem is what we want to know. We classified what we want to know is the, oh, it's so fast. The question what we want to know is the availability of our services. That's we want to answer this question. What is the services distributed? How about their resilience to partial faults? The second problem is the risk. The risk. What is our service system is facing with the risks? What is their threat models? And the third is what we have an ambitious purpose to know what we have surveying will help us to find more information and more solutions to result the future internet. How we classify this into two categories? The first category is routing. For routing systems, we are interested in the availability. In the availability subcategory, we want to understand the resilience. What is the routing system, especially the BGP system, resilient to the partial faults? As you know, the partial BGP fault is very will make this some of the region cannot be reached by the other side of the world. The other is the risk. What is the in these subcategories, we are interested to know the possible BGP hijacking threats. For the internet services, we want to know the availability, that is the distribution of these internet services, and the risk is no security issues. For both of these two subcategories, we follow a rather similar process. We collected data and analyze and geolocation and class them into a visualization. This is a big graph of our performance, our efforts. We think the cyberspace survey and mapping is key to understand the current cyberspace and shed light on the future. That is our dream. Now the first category is routing robustness. It's also the routing resilience. As Professor An Chengqing has introduced, the routing resilience, we are focused on the BGP public data. The purpose of analyze the BGP routing resilience, we define the routing robustness indicator. That is RETU. The RETU is or if some partial faults has happened, we want to know the site numbers of achievable or reachable, the RETU from reachable to all the sites. That is the RETU. And since a region may have many AS, so we use hierarchical sampling to know the areas routing robustness indicator. That is in a region there is several AS. For each AS, we evaluate its partial robustness problem, the robustness indicator, and use the sampling to achieve the robustness indicator of the total area. This is the destruction is simulated to approximate the damage situation of the real world area. This is the routing robustness definition. The results is indicated in the right figure. It's not very clear. We compared 50 region and nations that they are ranked from left to right. Is since the data set is we use is different, we have several categories, but the result is roughly the same. For this results, we can see compared with 2020. This is two findings of us. Compared to 2020, the robustness of 2022 in most regions has been greatly improved. And Argentina, Bulgaria, Chile, and Colombia have the largest improvements. That is a finding. And among the top ranked resilience nation or regions, the United States, Russia, Brazil, Germany, and India have a better robustness indication ranking. In Asia, except India, the South Korea, Japan, and Indonesia also very high ranking. About possible BGP hijacking, as introduced by Professor An Chengqing, we also used the multiple origin AS events to detect possible BGP hijacking. The MOAS, the basic idea of the MOAS is that IP address prefix is declared by two AS. Although in some cases this is normal, this is legitimate, but we use some information we can filter out that is legitimate and detect some possible BGP hijacking. We report the events, even severity level by the importance of the hijacked prefix and the victim's AS. This is the standard of our classification. If the number of websites contained in the hijacked prefix is greater than 5, the event is reported as a high level risk. And if it's between 1 and 5, the victim AS is, or the victim AS is an IDC or CDN or top level ICP, the event is linked as middle level risk, and all other is low level risk. This is our results and findings. The first result is the most routing prefix hijacking events do not have very big impact. That is that about 60% of the events only observed by less than 20% of the watch point. That is to say, most of our BGP hijacking is database. The fourth is VPN, and the fifth is industrial internet, and that is blockchain honeypot. I just it's a toy. This is internet services distribution. A very interesting finding is our internet services number and the population. The y-axis is the internet service number, and the x-axis is the population. From this graph, we can find that for cities less than 5 million population, the Frankfurt and the Amsterdam, Paris, Los Angeles have more internet services, and for cities with more than 5 million to 10 million population, the Hong Kong, Singapore, Sydney, and Hanoi, London have a large number of internet services. For super large cities, that is a population larger than 10 million, the Seoul, Tokyo, and Beijing have more internet services. That is a finding. For the component, the makeup of the infrastructure, industrial video, VPN, and honeypot, for the infrastructure, internet infrastructure, the most of infrastructure is Amazon's CloudFront. The second largest is Encapsula and Cloudflare. That is the industrial components, the makeup of the industrial internet. For industrial internet, the Xiaomi and the Tritium and IAC controller and Siemens have the biggest player in this category. For VPN, the IKE-based VPN is the major part of the VPN service provider. For the this is honeypot. The cable honeypot is the major player of the VPN service provider, and the right side is the video devices. The most of video devices, about 80% of video devices are from Hikvision Corporation or in China. Okay, let's summarize our findings in the network services. The network services can be an indicator of real-world society. The first is, for example, in Vietnam, the Ho Chi Minh City and Hanoi City have similar internet service number, indicating a parallel development. Another situation is in South Korea and Japan. In such nations, the Tokyo and the Seoul have a very large number of internet services, which reflect that in such nations, the network services are focused in their capital city. In some of the nations, for example, in United States, Brazil, India, and Turkey, the number of network service number in the capital is much smaller than that of the largest cities. That is a very different situation. The top three cities by the network service number is Hong Kong, Los Angeles, and Seoul. The last category is the internet service security. We find vulnerabilities by inference from the identified protocol and the server spanners, and compare them with the CVE database. The security index is measured ratio of the number of network services to the number of possible vulnerabilities. To be more intuitive, we use a logarithmic treatment similar to decibel. That is, the formula is our calculation algorithm. This map is the security index reflected by the capital city. More darker, the capital city is more secure. From this map, we can see that the America, both North America and South America and Europe and Australia, is considerably more secure than the rest of the world. For the cities, Hong Kong, Los Angeles, and New Delhi are more secure, and that reflects the fact that the more internet services or less internet service do not imply a better security level. That means that it's not to say more internet services number imply a better security level or LAN's internet services reflect better security level. They are usually they can be considered as independent. If you make more efforts on the network security, your network will be secure. Okay, that's the four categories of our survey and mapping. The last one is conclusions. What we achieved through this process is three. The first is what we are doing currently. Currently, we measure, analyze, discover, and visualize the cyberspace resources and their relationships. Network services and routing systems are the most important building blocks in our surveying and mapping. This is our current approach. In the future efforts, since the cyberspace surveying and mapping is a very complex system, it's a complex combination of physical domain, logical domain, and social domain. It can provide many aspects of information that the cross-discipline research may be necessary to understand cyberspace. It's not a discipline or a knowledge exclusive can be achieved by the cyberspace, by the internet technology. It also can to use the other disciplines knowledge. The third is the limitations of our research. The problem of our research is the data. Data may not be perfect, and what limited by our process of to achieve the data may not be perfect, may not be complete. Analyze may not be very, very complete. However, the statistics in this report may provide insight for the future survey and the mapping practices. That's it for my talk, and thank you for your attention. Any comments? Thank you.
Index for different cities. I didn't understand the equation where you explained that equation, the logarithmic equation. The index that you're showing for different cities in a map.
Yeah, security index. This formula. Logarithm function. This is log function. Yeah, log function is the end to do it. It's log. 对。Use log. That's it.
Understand. And the next page, can you show me the next page of this?
Okay. This is a map.
Oh, virtual. Okay, thank you. Thank you. I have asked my question. Okay, I was just asking about the question how the index of these cities have been calculated. Professor has shown us the equation, and then I looked at our country. I mean Bangladesh. What is the index of our country? And it saw it's below 3.30, the security level. No, Dhaka is not shown here, but I can see the country, Bangladesh. You can see the white.
Sorry, the city is in this
Probably.
in this figure.
Dhaka is not here in this map as well.
No, I don't think Dhaka from Bangladesh.
Kuala Lumpur. Okay, thank you.
Yeah.
To be between Beijing and New Delhi. Yeah. It's still so. I think more than 20 minutes. Thank you. Thanks to the next talk from Qianli. Next, our talk is from Mohammed Tarid. He has 29 years of experience in telecommunications and data communication field, and he has been working as chief executive officer of BD-RAN since April 2019. During his tenure in BD-RAN, he was involved in the design and implementation of a full research and education network. He joined IPANS. Now his talk is about the one of the using experience of BGP Watch. Now please. Thank you. No.
No, it is working. It is working. Click the wrong button. Welcome.
Change the computer, we can change the device.
No, it will come. Don't worry.
Yeah,
No, don't touch. It will come as it came before.
okay. It's okay.
I didn't touch. Don't touch. But it is off screen. Yeah. top left, there is nothing. Only black. Yeah, I got it. So, great. Thank you. But I cannot see. No, I cannot see. So let me try in a different way. Yeah, now it is okay. Thank you. Okay, so my topic is features of BGP Watch portal and a few suggested changes. Already it is little bit covered by Professor Chengwen. So thanks a lot for slides. I can very quickly go through those slides which you have already covered, but mostly I will focus on the suggested changes. Okay, the changes have been suggested with all my limitations. I have gone through other BGP Watch portal, but before starting my presentation, I should thank Tsinghua University for coming up with such an initiative from an end-to-end perspective. So it's a brilliant effort, that is for sure. Now it depends on we people, as we need to increase the adjacency. Suppose Hurricane Electric, they have around 10,000 adjacency. So they have more data to focus and to report on. But this portal, it has probably only adjacency. So the more the adjacency will increase, the more reverse routing path will be available. The IP addresses, the reachability of IP addresses will be clearer. So with that, let me start my presentation with some notable features. I have pointed out there are many features. So I have pointed out the dashboard, that is a notable feature. The routing path and topology, that is another one I will highlight. The coverage of autonomous system, the cone size. For the first time in my life, I found the cone size. So I had to go to internet and find out what a cone size is. This is nothing but the number of customers or BGP peers as customers with the associated autonomous system. Then subscription and reporting, I will part, and the anomaly, the reported anomaly, and I found some of the anomalies in the reported anomaly. So I will highlight that. This is the dashboard as Ms. Chengwen has already described. So in this dashboard, you can put any AS number and the associated, the country to which this AS belongs, the AS name, and the organization name, the owner of the AS, all will be displayed. And the number of IPv4 and IPv6 prefixes will be displayed. Suppose there are three tabs. So the first one is basic tab. If you click on the IPv4 peers tab, the top 32 IPv4 peers will be displayed. If you click on IPv6 tab, then the top 32 IPv6 peers will be displayed. And at the bottom, if you want to see all the peers or all the adjacencies of that AS number, you can go to the bottom, and in the bottom there are filters, whether you want to see peers, whether you want to see providers, or whether you want to see customers. So you can display all the adjacencies with that AS number. So in the top you can see, you can put the AS number for getting the information, basic information, IPv4 peer information, and IPv6 peer information. Then there is routing path. If you put the IP prefix, then the routing path from that NREN. Actually, in the top, you can see APAN55, ARNet, BDREN, SARNet. So in this case, SARNet is the source, and the prefix, we put here 103.28.120/22. That is the BDRN prefix. So all the way from SARNet to BDRN, the path will be displayed. So this can be a forward routing path from SARNet to this IP prefix. For IPv6 prefix, the same will be applicable, as Professor Changwin has already mentioned, that you in the IP prefix list, if you put a prefix, all the supernets and subnets will be displayed, and it will be because each subnet may be reachable through a different path. So if you click on the subnet, then the path will be displayed with, so you see here green color. So this subnet, which is in background, the bottommost one, it is reachable through this path. It will show with arrow keys. If you click on any other subnet, the path might be changed and it will be indicated by the corresponding color. This is routing topology. I found it very, very interesting. So what is routing topology? You can put any prefix over there. So we put 103.28.120. I have analyzed with only one prefix for your better understanding. So you can see that it is connected with 63961 AS. So that is one revelation. The second thing, you can put any ASN. I put here the SARNet 1 4538. Then from SARNet all the way to that prefix, the path will be available. You can see from 4538, it is moving to 23911, then 24489, then it is all the way reaching 63961. And at the bottom right corner, you will see the information layer wise. Layer 0 is the AS which is actually the nearest from the prefix, and 4538, it is in layer 5, that is the remotest from the prefix. So this is also a clickable chart. If you want to see only from layer 2 to layer 0, you have to click on layer 3, then all the layers will be hidden. Layer 3, layer 4 and layer 5 will be hidden, and you will see from layer 2 to layer 0 traffic, the layer 2 to layer 0 routing path. So this is very, very interesting. And this has been done for you to understand the similarity between routing topology and routing path. You can see the routing path, forward routing path from 4538 to 63961. The path is displayed for the prefix 103.28.120. The same will be available if you use routing topology. You have to put there the routing prefix, and you have to put ASN as the source ASN. So we put 103.28.120 as the destination prefix and 4538 as the source ASN. There is another good feature, that is bidirectional routing path. To avail this feature, you have to put two IP addresses, one at the left and one at the right. So we put 103.28.120 at the left and 202.205.1120 at the right, and then the forwarding path was available, but the backward path was not available. So I spoke with professor, and she told me that she will talk to the developer and will come up with the answer. Then the cone size, as I have mentioned, that if you want to know how big an ASN is, you can go to the cone size and you can find the cone size countrywide. So you have to first select Asia. To get Bangladesh, you have to first select Asia, and I selected BD. And all the Bangladesh ASNs will show up as per their cone size. And if you want to display the cone size of a particular ASN, then you can put the ASN number. I put 63961 as BDRN number. So I got the cone size of BDRN in the map. Here I had one suggestion that we can list the top 10 organizations with higher cone size. Then that will give me a feelings about the size of the ASNs which my country or the organizations of my country are having at this moment. And that will give me an idea about the relative position of my organization. So as Professor has already mentioned, the advantage of subscribing your autonomous system. So there is a register button through which you can register yourself. So once you register yourself, you will get an additional menu. That is, you can see at the top right corner, there is subscribe. If you don't log in, you won't get subscribe. So what is the advantage of getting subscribe? You can go there, you can subscribe your ASN number over there. Then all the anomalies that will be done to that particular ASN will be reported to you in the website, in the web portal, and also over your registered email. So that is the advantage of getting registered. So I had some comments in the dashboard. You can put any prefix over there, but let me show you. In the dashboard, if I put a sub prefix over there, then you get the main prefix. Suppose 103.28.121.0/24 is a sub prefix of 120.0/22. So it is displayed in the routing path. Okay, but in the dashboard, if we put it here, then there is no data. Probably Professor, I have shown it to Professor. She will talk to her developer to fix that. And the routing topology versus reverse routing path, to me, it is almost similar, although Professor didn't agree with me last afternoon. She said that this is much more detailed information is displayed than the reverse routing path, than the routing topology. Reverse routing path is more detailed. So I told her that if you want to keep this, it should be generated as a PDF file. You can see I have generated it as an image file and nothing can be read. So it is not legible. So Professor has given her words that she will convert it to PDF. I have already explained it, so I may skip this slide. That what is the use of routing topology slide. You can put your prefix, you can put your ASN, and also you can display it with layer-wise information. And in the reporting anomaly, so that is another feature. You can get all the high prefixes and also the sub-hijack prefixes. So between hijack prefix and sub-hijack prefix, the difference is only if it is a sub-prefix of the main prefix, then we call it sub-hijack. If it is the main prefix, then we call it hijack. And there are two categories of hijacking. One is possible hijack and one is ongoing hijack. If it is possible hijack, that means it will have a start time and an end time. And if it is an ongoing hijack, that means hijack is still ongoing. So it will only have start time, no end time, no duration. So in this slide, you will get under the event info, you can see that victim is displayed and also the attacker is displayed. The hijacked IP is 91.101.24.0/22. But here it is mentioned that 4 sub prefixes have been hijacked. But in this portal or in this page, only one prefix is displayed, so it is incomplete. So professor has explained to me that there is no space. So I told her that it is better not to put it here because there is a detail button at the right. If we click that detail button, automatically you will get the 4 sub prefixes. So over there, it is better to avoid keeping one prefix because it creates confusion. And in this page, time zone is not defined. So it is better to define the time zone. Then it will be easier to map all the data. And there is one more recommendation side. Suppose here we found that 20853 is the hijacker. So if we find an hijacker, normally the system generates a mail to the hijacker ASN administrator that this prefix has been hijacked or your ASN has hijacked this prefix. So I was telling her, or I was giving my suggestion, that the upstream AS should also be informed that a downstream AS under that upstream AS have hijacked this prefix so that they can also take measures. Otherwise, the hijacker might not care that, okay, fine, I have hijacked, but who cares? So it is better to inform the upstream ASN administrator that under your territory or under your domain or under your control, another ASN has hijacked this prefix. So some false alarm is there. So I don't know whether you can see it. It is very difficult to see. Here it is reported that the attacker is from AS20853 for IP prefix 185.24.1090. So when I made a search in the APNIC database, I found that this prefix, the owner is 20853. So it's a false alarm actually. So I told the professor, probably they will take care, but to me, it is probably because of some updating of recording problem. Because what Tsinghua University is doing, this flowchart, I have actually made up this flowchart. I didn't get it from anywhere, but this is my speculation, the way the false alarm is getting generated. So they are collecting the BGP route from the BGP route table, and they are collecting the origination from the routing table. Okay. And they are matching it with the ownership from the RIR database. But I don't know how frequently the RIR database is getting updated. If it is not regularly updated, if it remains static, then any recent change will not be reported or will not be reflected. So automatically that prefix will be shown as hijack prefix. So most probably that created, I think professor herself will be able to better explain it. Some suggested changes: the organization name, that is case sensitive. It is better to make it case insensitive. Normally, we don't know how BDRN is spelled, whether it is case sensitive or whether it is uppercase or lowercase. We don't know that. The prefixes dashboard IPv4 peers and that of routing path. In both the menu, we have the prefixes, total number of prefixes of a particular ASN. That doesn't match. So I think they should match. And for any static record, the last date of update should be there. If it is there, then many of the anomalies can be detected or can be understood. We can get the root. And there are only two recommendations. I think the working groups, they should be more active, and all the information should be shared between the members of the working group. That will help the transfer of technology. That is one of the mottos of this project, because Tsinghua University is doing a great work, but we want to be part of it. So the transfer of technology should be there, and that can only be done through the working groups. And the number of adjacency, which I have already mentioned, we have only 14 adjacency. So the more the adjacencies will be there, the more prefixes, the route to the prefixes, how we can reach those prefixes from any ASNs will be available. Without that many adjacencies, sometimes the paths, or if we try to report it, it will say that the ASN is missing. Thank you. That's all from my presentation. So if you have any question, I will be pleased to answer.
Couple of questions regarding the BGP was this part, right? Especially in the reverse route lookup, I also go through this site and say it seems okay, no issue, right? It's comparing to others like CIDA report as well, right? We can see some of the prefix is hijack. That means there is some false positive as well, right? That is the intended. That means from upstream providers, they announce their prefix based on the customer's request, and as well, it is fine, right? I think I also found the same problem in the here as well, right? We need to dig down and minimize those type of false report in the community.
Many of the false alarms are there. I have only reported only one, but I found many others, but I didn't report it. But this is probably causing from the frequency of the RIR database loading by this portal. I think that frequency should be increased. Professor can explain it better.
Yes, we will try to improve the system, and Dr. Torres give us very excellent, a very suggestion and comments, and we welcome comments and suggestions from you. And tomorrow I do an advertisement. Tomorrow we have a demo session for this system, so please join us. We have a video. Maybe we should share the video so everybody can know the system well.
Okay, so tomorrow a video will be shared and also a documentation, right? We shall share that documentation that has been prepared by BDRAN. So in preparing that video, we faced a lot of challenges and we could overcome all those challenges. Main challenge was it was very much dynamic. So once we were given the responsibility, the menu was something, okay? The menu got changed. So we had to change the documentation. But I appreciate the feedback from Tsinghua University. It was excellent. Even I tested her by sending an email at Saturday evening about this false alarm. Okay, I can remember. And she reported me back that this is a false alarm within 2 hours. So I really appreciate. Otherwise, if this cooperation was not there, this video or this documentation could not be made completed within such a short time. So, and I want to introduce Nafi Education. Sometimes we get oblivious about the real person who produced this or who actually is the creator of this work. So Mr. Nafio, he has created all the documentation and all the video part. Even the voice over there that has been recorded from his mouth. Okay, so we can give a big clap for him. So thank you, Nafi. So okay, see you tomorrow then, and let's continue with this program, right? Okay.
Thanks from the talk from Mr. Mohammed. Next talk is from Damika. Yeah, yes. His talk is user experience and suggestions to improve BGP Watch platform. He is also the user of BGP platform. Now, oh, okay. Thank you. Now let's begin our first talk. Yes, okay.
So, good evening to all. And this is also same as the presentation that done by the Mr. Taurit. So we'll be covering the same thing mostly. So that how we use this BGP Watch platform, our experience, and some thing we discovered that maybe some suggestions or maybe some issues that we discovered on this system. So how to go fast this so when we log into BGP Watch platform, we first come to the home page, right? So we see a page like this. So in this you can see some graphical views of victim and attackers, and we can click on those circles to see some numbers, number of attackers and victims. And also there are pie charts categorized by country wise, and also some bar charts by categorized by the number of the prefix length and number of counts of prefixes. So that's very useful. And so I have some suggestions on this first page, because it's better if we can enlarge the zoom or zoom this the central graphical part. That is sometimes this is small. If we can zoom, we can easily click. These are easily clickable. So likewise, these pie charts or the bar charts. So these are small. We can't enlarge them. So or we can't pop out them. So if we can have that, that's also very useful, because I think this information some some information are not shown in some other page, some other tabs. So that will be very useful. So next page is next tab is the overview tab. That's some overview page of what are about some statistics about hijacking and sub hijacking and things, and about we can filter the result based on the timeline, and also we can select search them based on the ASIN or country wise or region wise. So that's very helpful. So is when I search for the Sri Lanka region, we only found only few number of incidents happen. But I found some problem here when I click on this, and we can hover when we can hover on the here. So we can hover and go to the anomaly. But when I go to there, we couldn't find uh, the anomalies. There was this is not clear enough. Yes. These are okay. This okay. Okay. Now what to do? So this is the third tab that's about anomaly detection. So in anomaly detection, we can fill the results based on the event type, that is whether it's a hijack or sub hijack or ongoing event or the past event. Like, so also we can filter the results on the risk level, that's low or high or middle level. And we can also search by result or filter results by the prefix or country code or victim or attacker base. So in here, when I search for our ASIN number, it didn't give any result. Also, for when I search for this attacker colon LK and victim colon LK, whether at Sri Lanka has been an attack or victim, it didn't give any results for all the time. So I don't know whether it's we are not providing all the peering data or some maybe system issue. We can't assume right now. So there's a detail, like when we in the right side of the anomaly here, rightmost, we can there's a link for the detail to view the detail. When we click on, it will pop up in a new tab, new window, and there will be many parts we can view. So I since those are very lengthy, I will be parting them into few slides. So in the topmost, it shows when we click on anomaly, uh, these details, like its security, its risk level, or high in like here high level risk, a high level anomaly, and other details like victim is and hijacker is, and the country victim and hijacker countries, like details and shown. Since this is ongoing attack, only the start time is shown and not end time, because this is ongoing. So next, down that page, detail page, we can see some website. That's a feature included in BGP Watch platform that's useful. So what are the at least some website that is under that is hosted under those prefixes. So there are many websites. So if this is ongoing attack, so these websites may not be accessible. So down the detail page, in next section, so it shows the actually shows the some what the routing for routing path. So this is where this is the current routing path when the hijacker has hijacked that prefix. So hijacker those prefix, the current prefix is now directed to forwarded to the hijacker AS. So all the traffic will be directed to the hijacker. Also some other some minor forwarding routing paths are also shown. So that may be parts or sub prefixes are maybe sub prefixes of that prefix. So this is the actually the prior to the anomaly view, that is the uh, real original ACE path view before the attack. So this is some testing verification of that that listed site. So as I hope suggested, this site was not accessible. So when I search for the learn ASN, it didn't give any results, as I said earlier. So next tab is dashboard. So in dashboard we can view we can type the ASN and we can view the details of but that ASN. Like in this case, this is learn ASN number, and the down there it shows here it shows prefixes. It IPv4 prefixes it has, and also it shows here IPv prefixes it has. So but this results is very different from in terms of when we talk about the IPv prefixes, number of prefixes. Actually in other system like Hurricane Electric or other BGP view systems, actually it shows only 8 IPv4 prefixes, right? But here it shows 21 prefixes. Today morning why this happened, because that was due to some we are pairing with the Koga router. So they are actually I hadn't filtered the out prefix list, so I changed it to I filtered then the lower prefixes. Actually these all additional prefixes are lower prefixes than prefix length, the higher prefix length than 22, like 24, 30 prefix length. So those are those were somehow mistakenly announced to the this collector router. So I filtered I but then I cleared the BGP session. So then I checked the advertised routes, then those were okay. When I did that was okay, but this system has not updated somehow. I don't know. So yeah, those issues. So in the same tab, in the they are down there. We earlier saw the basic tab. Now there's also IPv4 peers tab and IPv6 peers tab. There we can see the peers, IPv peers with learn ASN. Here in blue colors we can see our local ISP and NKN peers, and their relationships are shown, that provider and customer, or whether peer-to-peer relationship. And also you can see with these numbers, it shows that a number of prefixes announced to each site. So down there in the same tab, it shows in this table format the same information. I'm not discussing about the IPv6 tab because same as the IPv4. And talking about next tab, that is routing path. That's very informational, and I think that's one of the most important next to the detection system feature in this platform. So here in this example, I have searched for the forward routing path from Learn ASN to some office.com, that Microsoft. So this is the ASN path there. So that's very useful feature. So next, this is the reverse routing path. So it's like hierarchical tree. So this shows actually how our ASN or our prefix can be reached by the other parts of the world, other parts of the ASNs. So this is actually small part. It's very wider screen. So as I captured this, some shot. Here I am suggesting if we can hover here in these circles or ASN nodes, if it's better if we can see the some ASN details. So next under the routing path, which is the reverse routing topology. So say we want to our prefix is 192.248.0.0/17. So we want to check. You say we want to check some reverse routing from some other known ASN. So we can put that particular ASN here 7575 on the right side. So when we search, it will show the particular reverse routing path. Other feature is by routing path. That is, if we enter source and destination from and in the left and right side, it will show up both reverse and forwarding routing path. Here I'm sorry that I earlier couldn't discuss with you, but I found this some results of this. It looks like to me it looks like the forward routing and reverse routing path are like swapped in this case, like I saw. So by right, so it's somehow swapped, like I feel when I search with several example, I saw that. I hope it's maybe a simple mistake like swapping, or maybe due to lack of testing or something, maybe. Yes. Yeah. Next tab shows country regional wise, actually is rank topology. So to view my LK, that's country Sri Lanka country wise is rank topology. I have to select the Asia and next next LK. There, there we can actually filter the results by the cone size. Is cone size. The cone size, as Mr. Taurit said, it is the customer number of customers, downstream customers. So in Sri Lanka, the maximum, as I saw, maximum cone size was 56, very low. So when I, as you can see here, I can filter the result, like to show the graph from cone size 2 to 60. So 2 to 60 in Sri Lanka, only these few 4 nodes will be shown. Oh, 5. So likewise, in the down there, in these bar, we can also adjust the font size limits, and we can filter these topology. So the lastly, I have some suggestions. So I think we talked about earlier in the project about mitigation, so hijack detection and mitigation features. So I think it's very good if it's been implemented somehow. And other thing is monitoring or alerting. When I think we are normally having some service to Google or Microsoft or some particular service constantly that we are normally using. So if we can somehow configure that topology here and like subscription, so in case that S-pass is changed, we can have an alert. Like earlier you requested that prefix length, change of prefixes. Like it was done earlier and it was done. Yeah, we are receiving that. Thank you. And the other suggestion, application program interface, that's the API. If we can actually, this is a very good backend. So very large effort by the Dragon Lab. So in order to use these big platform backend features, it's better to have it's much appreciated to have this API like a RESTful APIs, so that others can take advantage of these features. So then actually the customers or partners can partners can customize their applications and monitoring systems. So very useful. And other thing is yeah, I told about this some topology, some diagram. It should be, when popping up, that's a graphical thing. It's better if we can show the details in the when we hover, like what is in the description. Otherwise we have to go back to some system web portal and search the other details. So these are the all from my end learning. Thank you.
Any questions? Okay, thanks from talk from Miha. Now we have finished our 4 talks today. The first talk is from Professor An Changqing. Her talk is about the BJP Watch platform. The second talk is our survey of our BJP Watch platform. The third and the fourth talk are about the user experience and recommendations for our BJP platform. I think in the future, our platform will be much better, and we hope more users can use our BJP platform. Tomorrow, we have a BJP platform demonstration, and welcome to join our BJP platform. Thank you.